produce in the laboratory, you can produce it in the laboratory, and it's called a relaxation oscillator. And electrical engineers use it and have used it for decades. The idea of producing pulses every few milliseconds is a sophomore level experiment in an electrical engineering laboratory. It doesn't require neutronium, strange matter, or any other fictitious device. All it requires is two capacitors, a battery, and a nonlinear resistor. And we maintain that that's exactly what a binary pair of stars connected by a plasma field presents. A typical ion in the solar wind, hydrogen nucleus, moving about 20 kilometers per second, which is relatively slow for the ions in the solar wind, in the magnetic field of the sun, experiences potentially magnetic forces that are something like 10 million times the strength of the gravitational force on that same ion from the sun. An interesting demonstration that illustrates very readily the relative strength of magnetic force and gravitational force is the simple idea of a ball bearing sitting on a wooden table. The entire mass of the Earth is pulling downward on that little ball bearing, and that's what prevents it from flying out into space. But a child can come along with a little horseshoe magnet and click, pick that ball bearing up instantly.
The space age presents us with an interesting paradox. The technology of science is really quite extraordinary, and technology has taken us out into space, taken us to the moon, taken probes to distant planets, opened up whole new vistas in remote space with new telescopes and new ways of measuring what's happening in space. But the picture of theoretical science is much different. And many decades ago, assumptions began to crystallize in the theoretical sciences, beginning at the top, the queen of the sciences, as we say, which is cosmology. These theoretical assumptions have constrained all of the other theoretical sciences. Cosmology deals with the big picture questions, the first questions. How did the universe begin? What is it made of? How will it end? And so many popular theoretical constructs, from the Big Bang to string theory to dark matter and black holes, the formation of stars, formation of galaxies, all have arisen from assumptions first postulated by cosmologists. At the same time, these assumptions have defined boundaries for other theoretical sciences, working down from astronomy and astrophysics to the space sciences, solar theory, even Earth history, even human history, have all been confined by these boundaries established by the queen of the sciences, cosmology. The sun just dominates our sky as the source of light and warmth and life itself on Earth. And this preeminence of the sun is so clear and obvious that it remains a mystery why virtually every ancient culture insisted that before the present sun, there was a quite different luminary ruling the sky. The central sun, the superior sun, the best sun, the motionless sun. And all of these cultures, whatever may be the meaning of these traditions, are insisting that the sky has changed. Of course, our ideas about the sun have continually changed. Only a few centuries ago, the sun was a campfire or ember in the sky. Then early in the 20th century, under the influence of gravitational theory, the sun was seen as a gravitationally collapsing nebular cloud. In the atomic age, astronomers began to visualize the sun in terms of a nuclear furnace hidden at its core. But now we're in the age of plasma science, with discoveries of the electric currents in space. And it's inconceivable that these discoveries would not change the picture of the sun again.
Plasma cosmologists have been able to demonstrate experimentally and also in the supercomputer that galaxies are an electrical phenomenon, which raises the question about stars, and in particular our own sun, which is the closest star to the Earth, of course. Any theory of the sun has to explain how it could continue to burn for billions of years, and also explain its present size based on its known mass. And of course, as soon as nuclear energy was discovered, it was grasped immediately as the energy source of the sun. But all of that assumes that the sun is disconnected and an isolated body, and that it must consume itself over its lifetime to provide the heat and light that we receive from it. But if the sun is connected to the rest of the galaxy in an electrical sense, it doesn't require to burn itself at all. And the energy that we receive is actually being received from the galaxy, and the sun is acting as a focus for that energy.
The sun is actually a fairly typical star. And so if we want to understand stars and cosmology, we really have to understand the sun. And the standard model of the sun, so-called, that astronomers are so very proud of these days, really doesn't explain very much about the sun. Why is there a corona in the first place? Everybody knows about the corona, the beautiful corona that we see during solar eclipses. Why is it there? It's clearly an electrical phenomenon.
One of the greatest puzzles about the sun has been, with a surface temperature of 6,000 degrees, high above that surface we have temperatures of millions of degrees. And the question has been, how do we get the energy from the center of the sun somehow past that surface to heat the upper atmosphere of the sun to millions of degrees? In the electric model, you don't have that problem, because if the energy is arriving from outside the sun, the first place you expect to see that energy expressed is above the sun in its tenuous atmosphere. And that is the place where particle acceleration occurs, and the apparent temperature goes very high indeed, up into the millions of degrees.
The fact that the particles in the solar wind accelerate, that is to say, increase their velocity with increasing distance away from the sun, the farther away they get, the faster they go. And the fact that those particles are indeed charged particles leads me, as an electrical engineer, to come to the immediate conclusion that this is an electrical process. In the solar model, think of the sun as being a positive anode, very high voltage body that obviously would emanate an electric field. And if you put a charged particle in an electric field, it will accelerate. That's the way we accelerate particles here on Earth. It's the way every physicist and electrodynamicist has ever increased the velocity of a charged particle, is put it in an electric field.
One of the features we observe on the sun, which have no business being there according to the standard model, are sunspots. The most significant thing about a sunspot is the fact that the center of the sunspot is dark. And if the sun is trying to radiate energy from its core into space, we should expect that it is bright.
And if you think about that umbra, that darkest place in the center of sunspots, that's the place where we can see deepest into the sun. And just consider the fact that at that point where we can really see down into the sun, that's the absolute coldest place that we are able to measure. If the center of the sun is really a nuclear fusion furnace, it should be the hottest because we're closest to the source, and it's not the case. If you ask any astronomer, why are there sunspots? Why are the umbra dark? They will blame it on some sort of warped, twisted magnetic fields. They will say that it has to do with the solar dynamo, all of which lurk unseen like a big genie somewhere below the surface. These phenomena are only to be expected if the sun is electrical in nature. Astrophysicists make the claim that the solar fusion model has indeed been tested in the laboratory, and nothing really is further from the truth. Although each of the steps involved in the hydrogen to helium fusion reaction have indeed been verified experimentally, the overall experiment, the overall reaction, has never been produced in a continuous laboratory experiment. Continuous hydrogen to helium fusion has not been attained in the lab. The strength, in fact, of the electric cosmology is that indeed all of the mechanisms that the electrical people talk about have indeed been verified over decades, in fact, at least a century, in the laboratory. The plasma scaling is well known, and plasma and electrical experiments have verified every step of the way. There are any number of observations that have ad hoc present explanations, but really have no explanation in the standard model, and are natural consequences of the electrical model. For example, heavy elements, the solar spectrum, the neutrino deficiency, the neutrino variability, solar atmosphere, differential rotation by latitude, differential rotation by depth, equatorial plasma torus, sunspots, sunspot migration, the sunspot penumbra, and the sunspot cycle itself. Magnetic field strength, the even magnetic field, helioseismology, the solar density, and the changing size. All of the observations that in that list are natural consequences of the electrical sun model. Standard astronomers tend to pass them off as being inconsequential difficulties that will eventually someday be solved. I maintain, and so do our colleagues here, that these are not inconsequential, but are rather death blows to the solar fusion model, because they are important. They're not secondary. They're primary falsifying observations for that failed nuclear fusion model.
What I find so fascinating about the electric model of the sun is not just that it's a challenge to long-standing theory, but that it opens the door to the ancient world, to an electric sky. The electromagnetic phenomena that we now observe on the surface of the sun and in the vicinity of the sun are direct pointers backwards to the plasma formations that were seen above the ancient sky worshippers.
Electrical currents in space can either be invisible or they can be visible. If they're very diffuse, in other words, there's very little energy per cubic meter, they will be invisible. But where that energy becomes concentrated, it will begin to glow. And we see this kind of thing in the ion tails of comets, for instance. Where the energy becomes very concentrated, we begin to see arcs and sparks, if you like, electrical discharge phenomena. The standard theory of comets comes from the view that the solar system was formed from a rotating cloud of gas and dust, and that the planets, in some fashion as yet unexplained completely, formed from most of that gas and dust, but there were leftovers. And the leftovers are beyond sight, outside the solar system, in a hypothetical Oort cloud, as it's called. We have no observational evidence for such a cloud. The electric universe model of comets is that they are actually parts of well-differentiated planetary bodies that have in the past suffered from electrical plasma discharge machining, and that some of the surface material has been lofted into space, so it is expected to be rocky. The second thing is that because comets trace an elongated orbit, both away from the sun and towards the sun. In that trajectory, it's charged